Hello, everybody. Our chosen topic is license plate recognition, and the motivation behind this project is very simple. There are varied applications for this, which includes toll collection systems, surveillance, and enforcement of traffic rules, and there are many more. And the task at hand for our project is pretty simple. We plan to upload the image of a vehicle as the input, and we will be detecting the license plate as shown in the first image from it. And the second task is to extract the contents of the license plate as plain text. To talk about our data set, the first data set that we're using is to detect the license plate in the image. It consists of the columns you can see on the slide. Image is a file name containing the image, and the corresponding label will be in label. And class would be 0 if the image has a license plate in it, and 1 if there isn't. And x and y center would be the center coordinates of the license plate in the image, and width and height are those of the license plate. As you can see, we have plotted the bounding box based on these values in this sample image. This is a scatter plot of all the centers of the license plates in our entire data set, and as you can see, this is not an even distribution, and we are eager to see what kind of bias or effect this would have on our results. The second dataset that we're using is for the text extraction part of our project, and it looks something like what you see on the right side. So there will be 62 directories in the dataset, each containing the 10 digits, 26 uppercase and 26 lowercase alphabets. And this dataset already accounts for variations like font style, which we would be seeing in license plates. To talk about our baseline, we have chosen an Inception ResNet model for the detection of license plates. I want you to note that our baseline only detects license plates in the images. Therefore, the text extraction part is something that we cannot compare with the baseline. That's just something that we want to do to see what the results look like. Now, since this license plate detection is treated as a regression problem, we have used R-squared score and mean squared error to evaluate the model, and as you can see, there is a significant difference between the training and test score, which made us realize that there is a lot of scope for improvement. If you can see the box plot that we've plotted based on the prediction, it is not as accurate as we'd like for it to be. Therefore, for the plate detection part, we are using YOLO v3 and contours, and for the character extraction part, CNN is the best option. And on applying our YOLO v3 and contours model, you can see that the license plate has been detected much more accurately than the baseline did. And this is how the contour would convert the license plate. And as you can see, we have performed character segmentation on the contour of the image, and each character is extracted individually based on the segments, and the CNN model would individually predict each of these images to arrive at our plain text output. To conclude, we are expecting to see a much better result on using YOLO v3 and contours for plate detection, and we are also eager to observe how the character segmentation works out. And we are aware that the scope for comparing our project with that of the baseline is limited to the license plate detection, and we'll let you know in our report how the character segmentation part goes.